Hello. Now we will be calculating the potential along the axial location of the dipole. So this point P is there along the axis of this dipole line joining these two charges. And this point P is at a distance x with respect to point O, which is the midpoint of the dipole. This dipole, which is having a charge q, and the distance between the charges is 2L. And we want to calculate the potential at point P due to this system. So this charge I am calling 1 and this charge I am calling 2. So because of these two charges, there will be separately we will be calculating the potential at point P. So there will be two potential we will calculate. One is V1 and another is V2. And to calculate the net potential Vp, we will be taking the algebraic sum of those two potential. That's what we are going to do. Now these potential V1 and V2, these are due to the point charges, and for the point charges we directly have a formula. So potential due to the point charges formula is 1 upon 4 pi epsilon naught q by r. This is the formula where q is the charge and the r is the distance of the point with respect to charge. So first I'll calculate V1. V1 is the potential due to this first charge, which is the minus q charge. So that will be 1 upon 4 pi epsilon naught minus q. Since in this formula we have to put the sign of the charge as well. Now the distance of this charge with respect to point P is x plus L. So we'll have x plus L. So that is the potential. I'll say it is equation 1. Now I'll calculate V2, which is the potential due to the second charge. That will be 1 upon 4 pi epsilon naught. Charge is q. This is plus q charge, so we don't have to put the sign there. And the distance of this charge with respect to point P is x minus of L. X minus L. Okay. So this is your equation 2. Now let's calculate the net potential at point P. Okay. So the net potential at point P will be using the formula V1 plus V2. Now let's add these two potentials. So if we add these two potentials, the 1 upon 4 pi epsilon naught we can take common. Along with that, the q will also come common. The remaining will be 1 upon x minus L, and the minus because there is a negative here with the charge. So x plus L. Okay, so let's do the calculation. So 1 upon 4 pi epsilon naught q times of x minus L, x plus L. So here it will go x plus L minus of x minus L. That will become 1 upon 4 pi epsilon naught q times of, this will become x square minus L square. Along with that, x plus L minus x plus L. So this x and x gets cancelled out. So this whole value will become 1 upon 4 pi epsilon naught 2ql upon x square minus L square. So what I'll do, I'll take x square common from here. So there will be 1 minus L square upon x square. So this is the potential at point P. Now see, in this case, this x is quite large compared to L. Since x is quite large compared to L, at any point of time, x by L we can assume that is tending towards 0. So here we are having, L by x. L by x we can assume that is tending towards 0. So here this L upon x whole square, we can assume this is 0. So in that case, the potential at point P will become 1 upon 4 pi epsilon naught. 2ql is the P. The dipole moment for this system P is 2 times of ql. So I'll write P upon x square. So that becomes the potential at a point which is along the axis of the dipole. So this formula, one should memorize this formula. We can directly calculate the potential along the axis of the dipole using this formula. Okay. Thank you.